Hey all, welcome back to our Go programming series. This is day 3 and we are stepping into some exciting concept today. Today we are diving into struts, methods, interfaces and bit of Go's powerful concurrency feature. Let's get started. So this one, first struts. Yeah, struts in Go are similar to classes in other languages, but they are simpler and more lightweight. A strut is a collection of fields which is perfect for grouping related data. Let's jump into this example. Let's say we want to create a person strut with fields for the name, age, and job title. This person strut allows us to store different types of information in one unit. To create person, we do something like this. So we are assigning the person and we are assigning name, Alice, age 30, and job title, engineer. Now we have a person named Alice who is age 30, works as an engineer. We access and modify any of these fields with the dot operator like p.name or p.age. Struts are foundational for building more complex data in Go. So get comfortable with these formats. So next, let's see about methods. Now we understand the struts. Let's move on to these methods. In Go, we can define methods that belong to a struts. For example, here p person before the function name is called receiver. It's how associate this introduce method with the person strut. We will call p.introduce. It will print out the personalized introduction based on the person's name, age, and job title. And just like that, we can use methods to add behavior to struts without creating classes. This is part of Go's philosophy of simplicity. Next, let's talk about interfaces. Interfaces in Go are a way to define behavior, and any type that has the required method automatically implements an interface. This allows us to write more flexible and reusable code. So here, let's create an interface called describer, which will describe an object with a single describe method. Yeah. Now, any type with a describe method that returns a string automatically satisfies the describer interface. Let's go back to our person strut and implement the describe method. So here, now person implements describer, we can create a function that takes a describer interface, meaning it can work with any type that satisfies describer. This function can accept any type that implements describe, which makes it really versatile. Go's interface system allows for flexibility while still keeping everything strongly typed, which is one of the unique strengths. Alright, let's move on to one of the Go's most powerful feature, concurrency. Go was built with concurrency in mind, making it easy to run code in parallel, which is great for making efficient and responsive applications. Go uses something called Go routines for concurrency. A Go routine is a lightweight thread managed by the Go runtime. You can start a Go routine by putting the Go keyword before a function call. Here is an example. When we call Go say hello, it returns say hello. The main program continues running at the same time, which is why we see both messages without waiting for say hello to finish. Now, because Go routines run independently, they don't always finish in specific order. If you want to control the timing or wait for all Go routines to finish, you will often use something called wait group. In this code, wait group is like a counter. We call wait group dot add one to add one Go routine and wait group dot done when the Go routine finishes. Wait group dot wait passes the main function until all Go routines are done. Go routine and wait groups are just the start of Go's concurrency model. In future lesson, we will cover channels, which are Go's way of sharing data safely across Go routines. Let's quickly see what we have seen today. We have seen struts, method, interfaces, concurrency. Struts, this lets us group data into single unit. It's like a class. Methods, we added functions to struts to give their behavior. Interfaces define a set of behaviors, make our code more flexible and reusable. Concurrency, we introduce Go routine and wait groups, Go's tool for running code in parallel. This is for this class. See something interesting in the next session.